create RDS database part 2. So now this database is created and the status is available, and let's just quick look at the configuration there. So first we have our connectivity, the endpoint and the port. Okay, so this is going to be our URL of the database. Okay, so it's a domain name, and the port number is 3306, the default MySQL port. Availability zone is the US East 1A, and the VPC is the default VPC, and we have 6 subnets for that, IPv4, and security group is this default security group. So this security group is used to protect our incoming and outgoing inbound, outbound traffic. Okay, public accessibility is yes. Okay, and CA, this is a HTTPS connectivity. All right, and then we have down there only one instance. Okay, so that's the replication, and no proxy of RDS. This is used to improve the performance of the, you can think of its connection pool. Okay, monitoring, so we have CPU usage, database connections, okay, and then the space, memory, okay, everything is there. Okay, IOPS, logs. Okay, we have a basic event log, and we didn't turn on a lot of like detailed logs, so we may just only have the error logs. Okay, and the configuration here, okay, is we have the engine version, okay, and also the parameters that we need to set up the database. Okay, the option groups. There's a parameter groups as well. Okay, so we can just take a look. It's basically just the parameters that we can manually set up, just like a real server. So we can change the configuration file of the database. Okay, so just like a lot of parameters there. And the storage, so everything. Okay, so it's listed there. Maintenance window. Okay, so that's that, and also have the backups. Okay, so this is all the informations are on the same console, okay, or UI, and also we have our snapshots for the backups. Okay, all right. So then we want to connect to this database. All right. So from here we cannot open any console. We can only connect to this database, okay, using the username, password that we give to when we create the database. Okay, so this is the provided URL. In order to connect to MySQL, we can use MySQL Workbench. Okay, so that's the Workbench, MySQL Workbench. Okay, so this is the official tool for the MySQL database. You can download it and use it as a RDBMS software, or we can use our IntelliJ. The IDE is showing up here. Let me quickly get it. Okay, so in the IntelliJ we have this database tools that can help us to connect to our MySQL database. We can just need to create a data source and then select MySQL, just like the old way we did to our local MySQL server. So here we have to change our local host to this here. Okay, copy this, and then host is this host, port number 3306, and then username, password as authentication, and the user is root. Okay, password is I put aabbccdd. Okay, so you have to use your own, and we can just save the password. Database we can leave it blank, and now we can just try to connect. Okay, so the connection URL is JDBC MySQL this string. Okay, it's no longer localhost. Now test. So usually it should be very fast, but let's see if we have this keep spinning, rotating issue. That means our connection is hanging and the server is not responding. Okay, so usually this is the case of connection issue. Okay, it's not connection refused. It's just you don't even have a connection to the server. The server don't even get the request. So firstly, you check, okay, if the database is not publicly accessible, then there's no way you can directly connect from my IntelliJ from, at home to AWS. But since this is publicly accessible, then there's another reason, is the security group. Okay, so if you look at the security group here and go to the inbound roles. Okay, so the inbound rules, we added it, and let's just take a look. All traffic, okay, so from range all the ports, any protocol from, okay, this is the source. Okay, so from this security group, this means that only this security group can access this server. Okay, so anything from this security group with this security group, basically. So, but we are connecting from our local computer, right? So definitely it's not. So if you have a server and that server has this security group like EC2 instance, then that instance can connect, okay, to the database. But for here, we are connecting directly from our local. So we need to add a role. We can just put, there should be MySQL here, okay. Basically just the port number, which is 06. You can also use customized IP and then put 06 there. Okay, it's IP address. So if you want anywhere, just choose anywhere. Okay, so anywhere or my IP address. So for more secured reason, right? So I just choose my home server. Okay, so not home server, sorry, home IP address. Okay, so make sure that's that, and then save. Okay, so once this is saved, now we have two entry in our secure group, and if we go back to our RDS, okay, so here it can show us this is the security group rules there, right? So this is my IP address. Now I can connect in. Okay, so this is inbound, and then we can here try to connect again. Okay, now you can see it's succeeded, right? So successfully we can connect to the database, and then we can just click on OK. Then it will connect to our database using the root user. All right, so that's the first step that we can take to connect to this database. But we don't have any database, right? This is my local MySQL. We have this SCP training database, but for this one we don't, because it's a brand new database. Okay, so we need to run some command here to create a new user and then create a new database. Okay, so I'll put the script in the description so that everybody can just copy paste, but it's basically the same process as we set up the local database. Okay, firstly we need to create a user. Okay, use create user command, okay, SCP user, we just to make it like the same as our code, and add any database identified by a password. Okay, so then the password we need to update later. Okay, so we can actually go to our previous GitHub, and we can get the setup script, and in the MySQL. Okay, and here you can see this is the command we use to set up our local database. Okay, create a user, right, and then identified with password. Okay, by. Okay, so this is the password. Okay, so we can put it here, and then some of the commands are not compatible with RDS. Okay, so we can just put this password here. Some of the commands are just like, if we create a database here. Okay, so create a database SCP training. Okay, let's just run this first. All right, and then we're gonna run this. Okay, so now we have the database created. Okay, then next is we have to give this user the privilege to operate on this database. Okay, so the command is different from this script now, because this script will just give the all the privilege, okay, to this user, but MySQL doesn't. Sorry, the RDS doesn't support this one. So if we put this here, oops, oh my goodness. Okay, if we put this here, it will give us an error. Okay, so it's just hiding there. This is new to me. Okay, so yeah, here we go. It give us this error saying that there's access denied, okay, for the user. So in order to change it, so there's a document in the AWS website. You can just Google like create new user from RDS, and you're gonna end up with this query. Okay, so basically you get all the privilege, okay, instead of just all, and then run it. Okay. All right, so now it's gone. Okay, so we can actually start using this SCP training using this user, SCP user, and aabbccdd, which is the same here, right? And we just need to change this URL. Previously, it was localhost, right? So 3306. And now we just need to change this to our own database endpoint, right? So just change to this one here. Okay, just only this is the database name, this is ID, and then this is the availability zone. Okay, if you have multiple replicas, okay, replications, and if you create a, let's see if we can create a read replicas, okay, then this URL could be multiple. Okay, so you can just choose which one you want to read the data from. So that could be changed. Okay, all right. Anyways, so now in my local computer, I try to connect to this database using SCP user and the password that we just set up. Okay, so let's see how it works. Let's restart the application, or if you don't, you just start it. Okay. All right, so now you can see everything works fine, right? And no error, no issue. Now if I shut it down and then I just change the password a little bit, okay? And let's see how it works. If I do this, and then you can see I use the wrong password, then the system refused to start, because when we start the Spring Boot application, it tried to connect to the database, and the password is wrong. Right, so that's why we got these errors there, and you see access denied for this, right? So that means our application is really trying to connect to the RDS in our AWS cloud, right? Instead of the local one. Okay, I have a local one open here, but this is a local host 3206. All right, so now let's start it normally, and let's test this URL. Okay, let's test this API. We can go to localhost 8080. This is our REST API and the ingredient. Okay, and then okay, so you can see the system is just give us 500, means that something is wrong. Okay, so it will tell us it's the table SCP training, the ingredient doesn't exist, right? So this is a correct, because we just create an empty database SCP training without any tables. Okay, so next we're gonna migrate our database, right? Because we already have a local one, we're gonna create the same one, okay, from this database to this database. For at this moment, it's gonna be a DBA's work, cause like how you migrate the data from one database to another database. So usually it won't be like this simple, like 4 tables. You're gonna maybe have 40 tables. Maybe you can have multiple different databases, and in the middle, probably the data should be masked, should be filtered out, right? Should be processed. So those are we have separate tools to do that. It's not in the scope of this training, but for the testing purpose, okay, we can actually have multiple approach. Like simply just put everything there. First is like the tables. We can actually ask the Hibernate to create those tables for us. We don't need to manually create the tables. Okay, all we need to do is we just need to put an attribute called Hibernate DDL to auto, okay, and then we make it create. Okay, so in this case, Hibernate will firstly check if you have the table or not. If you don't have the tables, Hibernate will create the tables according to our entity classes. Okay, so according to our class, Hibernate can create the tables there. Okay, so if we restart the application now with this and with this annotation, this configuration there, and you can see there are some errors at the beginning. Okay, basically they'll tell us like alter, okay, something which is not there, but in the end it will create the tables there. okay, and then alter the tables. And now if we look at the database, just refresh it, refresh this one. Okay, now you can see the tables are actually created. Okay, and then the dish table, okay, and then the ingredient table. So the tables are created. If the tables are created, then now if we query this database again, I mean this API, you can see now it gives us empty data. Okay, it works. Now its only thing is that we don't have the data in the tables. Okay, either we can manually add some records right here, or we can go to the local database, and then right click. There is a export. Okay, we can export our data from one database. It will just generate this SQL query, and then we can just run the query. Okay, so we can also ask it to generate the query to create the tables. Okay, or we can just toggle this DDL, and then it won't generate the create table. Okay, so that's the one way to export the data. If you want to export the tables, you can use SQL generator. Okay, and then it will generate all the creation query of the tables. Okay, so then we can just copy this and run it in the new database. So it will generate all the tables. Okay. Anyways, so I'm not gonna just run this insertion, but we can just manually create one record to see what it is. Okay, and we can just put here like apple. All right, and then commit the change. Okay, and then go back to the system, to the browser, and refresh. Okay, now I see we have the record. Okay, so now this record is saved in our RDS database, and our Spring Boot REST API application can actually successfully get the data out of that relational database. Okay, so then this is the whole section of creating our RDS database and then connect from our local Spring Boot application. Okay, so next we're gonna use our EC2 instance, the one that we uploaded by Docker. Okay, so the container is still there in the EC2 instance. We're gonna just start that one and connect to the RDS. Okay, same process. If you understand the flow, then that will be the same steps. Okay, so it's gonna be easier. Thanks.